So we're here to solve a little bit more complex looking problem. This problem is 2 cos cubed minus 3 cos squared equaling negative cosangle. Okay, so recognize that we can kind of think about this as if it's 2x cubed minus 3x squared equaling negative x. Okay, and we know how to solve this. You bring everything to one side and you solve for the roots. So that's exactly what we're going to do for this question, but we're just going to see cos as a term at the start. So what I'm going to need to do is I'm going to need to move my cosangle to one side. So I'm going to add cosangle to cancel these coses out. And I will get 2 cos cubed angle minus 3 cos squared angle plus cos angle. Okay, and this all equals 0. Now we're trying to figure out what values can we plug in for the angle to make this term equal 0. So effectively we're solving for the roots of this problem. The first thing I'm going to notice is every term has cos in it. So I can factor out a cosangle. So that's going to be my first step. Let's factor out this cosangle, and I will get 2 cos squared angle minus 3 cos angle plus 1. Okay, and this all equals 0. Now we have to factor by dissociation here. Okay, so my product is 2 times 1, so the front term, the leading term, multiplied by the constant. 2 times 1 is 2. So what numbers multiply together to get to this? My sum is my middle term, so negative 3. And those same two terms will add together to give me negative 3. So my answer here will be negative 2 and negative 1, right? Negative 2 times 1 gives me 2, and negative 2 minus 1 gives me negative 3. So I'm going to now represent that middle term, negative 3 cos angle, in terms of negative 2 and negative 1. So I still have my cosangle here. And now I will represent my middle term as minus 2 cos angle minus cosangle plus 1. Okay, and now here we are factoring by dissociation. So the first two terms in my quadratic, I will factor out common things, and my last two terms, I will factor out common things. So this simply just drops cosangle. And what's going to happen here is, what do these first two terms have in common? Well, they have 2 and a cos. So I'm going to factor out my 2 and my cosangle. So this leaves me cosangle minus 1. Now I want my last two terms, I want to factor it out to effectively get the same factor here. So I'm going to factor out that negative 1, and that's going to change my cosangle to positive cosangle minus 1. Okay, so now I have two common terms I can factor out. So I will have cosangle, remember, dropping this again, don't forget it. Factor out that cosangle minus 1. And that's going to leave you with 2 cosangle minus 1. Okay, and this all equals 0. I should have been dropping that equation symbol equaling 0 that entire time. Okay, because remember, that's an equation. You have an equal symbol, you have an equation. Now we can effectively find what value for angle here will make this expression 0. Because remember, if this expression is 0, the entire term, the entire equation turns 0, because 0 times anything is 0. Then what angle in here can I make this term 0? And then what angle here can I make this term 0? So we have effectively 3 things to solve. When does cosangle equal 0? When does cosangle minus 1 equal 0? And then lastly, when does 2 cosangle minus 1 equal 0? And remember, there's no restrictions on this problem. So we're going to be having to find general solutions. So let's focus on cosangle equaling 1 to start with. Well, cosangle equaling 1, if we think about a unit circle, remember, x and y on a unit circle is represented as cosangle, sine angle. Okay, so we're trying to figure out where is the x values that are 0. Well, our x values on our unit circle that equal 0 are found here and here. Okay, this is at pi over 2, and this is 3 pi over 2. Okay, now here your coordinate points are 0 and -1. Here your coordinate points are 0 and +1. Okay, but remember we just care about that x value. So you could write two general solutions. Okay, and our first one will start off with pi over 2. So if you start at pi over 2, okay, right here, pi over 2, if you start there, and as long as you add a full rotation, okay, 2 pi n, where n can be any integer, you will effectively be given a solution that has cos at 0, right? If we start here and we do a full rotation, we're at the same terminal arm. If you add another rotation, okay, you could keep going around and around and around. And that's the same way for negative values, right? N can be negative values, so we can go in the negative direction and still end up as long as a full rotation. And it's the same idea for 3 pi over 2. If we start off at 3 pi over 2 and we add a full rotation here, well, we will be given the general solution 3 pi over 2 plus 2 pi n, where n is any integer. Now recognize this can be represented by one general solution. Okay? And that's because if we start off at pi over 2 here, okay, so let's maybe draw a new circle. If we start off at pi over 2, and if we make a 180-degree rotation, we're at our 3 pi over 2. And then from there, if we make another 180-degree rotation, so on and so forth, we will always be ending up where cos is 0. So as long as we add a pi, an integer of pi, we're going to end up at pi over 2, because remember pi is 180 degrees, okay? And in this case, n can be any integer. Okay, and you can check this if you would like, but it will work. So pi over 2 plus pi n, okay? Now, let's move on to where cos angle equals 0. So cos angle equals 0, or cos angle minus 1 equals 0. I'm going to first add 1 to both sides. So I get cos angle equaling +1. Now it's the question of where does cos angle equal +1, aka where does x equal 1? Because remember, x and y on our unit circle is the ratio of cos angle and sine angle, okay, because your radius is 1. And x equals 1 in one point here, right? 1 and 0. And remember, we're finding the general solution. So this is not only at 0, this is at 2 pi, this is at 4 pi. You could also think about it at -2 pi, -4 pi, so on and so forth. So as long as we start at 0 and we add a 360-degree multiple, we will always end up where cos angle equals 1. So my angle here will be, you could put 0 here if you want, 0 plus 2 pi n, again, where n is any integer. So I'm going to represent this as simply 2 pi n, where n is any integer, because that 0 is effectively not doing anything there. So now we have two solutions. Let us find a remaining solution here. So where does 2 cos angle minus 1 equal 0? Well, I'm going to solve for cos angle. So 2 cos angle equals 1, and I'm going to divide 2. So cos angle equals 1/2. Okay, so where does cos angle equal 1/2? Again, let's draw our unit circle. And remember, you kind of want to understand your first quadrant and go from there. Okay, so your first quadrant, you're going to have an x-coordinate of 1/2 and a y-coordinate of √3/2 when your angle is 2 pi over 6, which also equals pi over 3, okay? But remember, this is a positive cos angle. cos angle is positive in not only your first quadrant, but also your fourth quadrant, okay? So down here, if you have a reference angle of pi over 3, okay, so this is acting as a reference angle, you are having a solution where your x-coordinate here is a half and your y-coordinate is negative, but we don't care about the y-coordinate because we're just talking about cos. And remember, on a unit circle, x and y can be represented as the ratio of cos angle and sine angle, okay? So your x here also is 1 over 2, okay? And at this point, you should be able to understand how to find this standard angle. Okay, this is 10 pi over 6, which also equals pi over 3. Okay, or sorry, 5 pi over 3. Okay, so now we have two solutions, but we need the general solution. So I'm going to focus on my solution here first, so pi over 3. So as long as we start at the angle pi over 3 and we add a full rotation multiple, we will always end up with a terminal arm at that point. So if we add 2 pi n, where n is any integer here, this is the general solution for our pi over 3 angle. How about the general solution for our 5 pi over 3? Well, you guessed right. If you guessed that as long as we do a full rotation starting at 5 pi over 3, and where n is any integer, we will solve this equation. Now recognize these aren't nicely split up by like a half of a rotation, 90 degrees or anything like that. So we're not going to combine these because they can't really be combined very nicely at all. So all in all, our final answer, your angle can be tons of different things. Okay, your angle can be pi over 2 as long as we go pi n integer. Can also be 2 pi n, where n is any integer, and then your angle can also be pi over 3 plus 2 pi n, where n is any integer, and lastly 5 pi over 3 plus 2 pi n, where n is any integer. Again, this is kind of a tougher example, but if you really understand this, I would suggest pausing the video, trying this example on your own and see if you can get the similar solution as I did, okay? If you're able to understand and walk yourself through this example, you will do very well in your trig equations.